So welcome all to the brown bag on security testing with the OWASP Top 10 and Burp Suite. So let's dive right in. Um, so first of all, who am I? Joko already introduced me a little bit, but my name is Bart. I've been working for Brightest for just over 3.5 years now. I started out as a functional software tester, including test automation. And gradually, I added non-functional areas to my interests, starting off with performance testing. And since about 1.5 years, that also includes security testing. Um, this also included developing a new solution for security testing at Brightest as the lead of a workforce with dedicated and bright team members with whom it's a real pleasure to sail the seas of security. So what will we be seeing in this brown bag? We'll start off with a short introduction, followed by a brief overview of the OWASP Top 10. And after that, I'll be showing the possibilities of Burp Suite, which is one of the industry standard tools for web application security testing. And finally, we'll finish off with a Q&A, as Joko already mentioned. So let me first of all emphasize that this brown bag does not aim at making you a cybersecurity specialist in our brief time together. The goal is mainly to introduce you to all the good stuff security testing has to offer you, and you can take it from there. So we'll see some general notions of security testing, and then afterwards a few practical examples in a demo. Some numbers. There is a hacker attack every 39 seconds. So by the time you upload a selfie to Instagram, someone somewhere or some company has been hacked. On average, hackers steal 75 records every second. And 75% of businesses does not have a formal cyber attack response plan. And every day, a staggering 300,000 pieces of malware are created. And of course, data breaches are costly at about $150 million a piece in 2020. And the cybersecurity budget in the US alone is almost $15 billion. And here you can see some examples of some famous hacks that occurred in the news. Most notably, the Log4j exploit that everybody probably heard about at some point. Then the RockU aggregation a couple of years ago of 8.4 billion user credentials that were aggregated in a TXT file of several gigabytes. And a security incident at LastPass a few weeks ago, where source code was stolen through a compromised account of one of the developers. And only last week, there was also a reported breach at Uber. And just yesterday, video game publisher Rockstar Games announced they were victim to a hacker who downloaded and shared images of their upcoming game GTA 6. As I mentioned before, cybersecurity in itself is a broad field of expertise. In fact, it's more of an umbrella term for the technical aspects of information security in general. Other aspects of information security are, among others, physical security and social engineering, which often goes hand in hand with cybersecurity, of course. Within cybersecurity, we can make a distinction between network security on one side, affecting firewalls, routers, etc., then IT security, which relates to host machines, and then application security, which is what we focus on in this brown bag and in Brightest as a company as well. And this is where OWASP comes into play. So this diagram you see here, it roughly sketches the relationship between the branches or the types of cybersecurity and the hardware and software that are affected by them, which goes from the outer layers of hardware starting at the network, inwards over the host where the application is hosted, and then the application and the data itself. And you can see on the left side that it corresponds to, so the network falls under the umbrella or the category of network security. The host falls under IT security, which is includes operating systems, etc. And then we have the application itself. And usually the data is what mostly occurs in the news when a hack has been done. That means that the data has been leaked. So that's our segue into OWASP, which is an organization specialized in everything that concerns web application security and more. It stands for the Open Web Application Security Project, even though in the meantime it covers a whole lot more than web applications alone. It's heavily industry and community driven, and every couple of years, they also perform research and surveys within the industry to determine a top 10 of common vulnerabilities. As I said, this started out for web applications only, but now it also includes lists for APIs and mobile security. So they have a very wide range of information about security in general. Aside from the top 10s themselves, they also offer a set of extensive guides on how to test for vulnerabilities. And on the other end of the spectrum, they also have sets of proactive controls for developers and a verification standard for the design phase of an application, which ties into the shift left movement in testing in general. Here we see a comparison chart of the OWASP top 10s of 2017 and 2021, which is the current version. I'm not going to go through all of them in detail for that. This session is a bit too short, of course. In any case, most of the categories that were present in 2017 also remain in the current version in 2021, which was released last year in September, I think, with a little bit of delay. And some of those categories have been merged or have moved position, and a couple of new categories have been added. Among others, there is one category which falls under the umbrella of the aforementioned shift left with insecure design, which is at position 4 currently. This is actually the least technical category, since it pertains mostly to requirements and business logic, so less to actual technology or the underlying code, let's say. So the other vulnerabilities, they range from direct attacks to the application itself or to the underlying infrastructure. And the examples we will see later in the demo fall under injection at number 3 and authentication failures at number 7. So all entries in the top 10 are also connected to CWEs, which is a list of general types of software weaknesses, so the common weakness enumeration. You can find lists of those in online clearinghouses like Mitre. And then you have CVEs, which are specific occurrences of CWEs in a certain software product. So in the example I have on the screenshot here, we can see a vulnerability in a version of the software MPDF. So it's in a very specific version of that software, and it contains a deserialization weakness. And that weakness, deserialization itself, falls under a common weakness enumeration. So it's not directly related to any specific software product. It's more like a general category. And some software might show that type of vulnerability. So now, how does security testing fit in the QA story? And how does it compare to functional testing as well? So there are a number of approaches to security testing, which goes from static security testing over dynamic to interactive and out of band. And as a software tester, both functional and non-functional, in most cases, you would fall under the category dynamic application security testing, which is outside in. It's also black box, so you don't have access to the code necessarily, and it's on a running application. When you hear the term penetration testing, usually, but not always, it refers to dynamic application security testing. And now let's look into one of the tools that you can use to test for security, with a very appropriate name at lunchtime, of course. So B𝗿𝗟𝘄𝘗 is a very powerful tool for manual dynamic security testing. They have a free community edition, which has most of the functionality. But one of the things you'll miss is an automatic vulnerability scanner, which is only available from the professional edition onwards. So in the professional edition and the enterprise edition. Furthermore, Burp has a built-in proxy and a browser you can use to explore applications. And it also has some out-of-the-box tools that offer a lot of additional functionality for repeating requests, performing bulk actions on them, and also triggering interactions to an external DNS server hosted by port trigger themselves. This one is also only available in the professional version. One of the most interesting features of this tool is the possibility to add extensions or plugins, which can range from adding additional checks to the scanner or add more tabs to the tool, to the software with some utilities for facilitating the manual testing. I'll show you that later in the demo as well. The main feature of Burp Suite is the proxy. That's where it all starts. And the proxy is something you can use to intercept requests from your browser. In this case, this is a forward proxy, meaning it intercepts the traffic between you or your machine and the web, as opposed to a reverse proxy, which is usually set up server-side as an additional layer of security, load balancing, and rate limiting. So that's more on the defensive side, let's say. And a reverse proxy serves as a catch-all or catches the traffic coming from the internet and determines if your traffic is allowed in the first place and where it needs to be directed to on the web server. So which service on the web server that it has to get the data from or the information from. In Burp, you have the possibility to set up multiple different forward proxies. And you can then use those multiple proxies to configure either in separate browsers or tools if needed. So you can separate traffic or requests for different target websites or software. If you would have a combination of web applications you would like to test, for example. The screenshot you see here is an example of the built-in vulnerability scanner. It's more notably the list of issues that are found after the scan has finished. And from here on out, you can investigate the specific path where this vulnerability was found. And Burp also provides a lot of details for each issue, often with tips for remediation or further manual testing. And what you also get is some references to CWEs or CVEs, so you can use this information to investigate further or to gather more information on what the vulnerability actually entails. There is one caveat with regards to the accuracy of the scanner. It doesn't always find all vulnerabilities, especially if they are a bit more obscure or obfuscated. So manual testing is always a must when you audit an application for security vulnerabilities. But the scanner is a good starting point, of course. So for the manual testing, you can either use the built-in browser in Burp Suite itself, which already has the proxy pre-configured, or you can use your own browser in which you have to configure the proxy. In the case of Firefox, you can use an extension for it, or you can set it up in the browser settings itself. And Chrome takes the proxy settings of your underlying operating system. So in Windows, you would have to configure the proxy in Windows itself, system-wide, to use it in Chrome. However, that would also mean that all the traffic passing through your Windows proxy is also intercepted. And there are two ways of intercepting the traffic. You can either intercept the requests directly as you navigate the website. And once it's intercepted, you can manipulate some data and then either forward the request to the browser again with the manipulated data in it, or you can drop the request entirely, which could be useful, for example, when you're trying to, when you're attempting to bypass certain validations on the application by skipping them entirely. And alternatively, and that's my preferable method, is that you just navigate and explore the website without directly intercepting the requests. And then you can use the proxy history in Burp Suite to filter and investigate specific requests. And from the proxy history, you can send any request to any of the other tools in Burp, including installed extensions. It's noteworthy that you can also use the proxy for intercepting traffic from Selenium or other automation tools. An OWASP ZEP or Z-Attack proxy is a solid alternative tool you can use for this, which has built-in Selenium support. But technically, you could use any type of automation and intercept all the traffic through the proxy and also, therefore, be able to consult that traffic in Burp Suite itself. So once you have gathered those requests in the proxy history, one of the next steps usually is to send a request to the repeater, which is one of the most useful functionalities in Burp Suite. It allows you to resend requests repeatedly to manipulate data such as headers, cookies, payloads, and then observe and compare the different responses you get back from the application. You can open multiple requests at once in separate tabs in the repeater. And the overall configuration also allows for adding all sorts of actions before and after each request. For example, you can add authentication headers from a login request so that each time you perform a request, first it logs in, fetches an authorization or a bearer token, adds it to the request, and then sends it, and then you can consult the response. And then afterwards, after the request has been sent, you can also process the result with regex expressions or some other processors to retrieve data from it to perform certain validations on the requests, etc. The intruder is another useful tool where you can perform different types of brute force attacks using payload lists to inject into variables which you define in the request. I'll also be showing this in the demo later. So in this example on the screenshots, we have two variables for the email and the password, and we would execute a cluster bomb attack, it's called, that will brute force any permutation of two lists with email addresses and passwords without knowing which password is linked to which email address. So that can, of course, be a very time-consuming process, especially if you use very large data sets. And also, you could have the case where the server has some rate limiting enforced, so that you can also only send a certain amount of requests at the same time or in close proximity. And then you also have the possibility in B𝗏𝗏 to set up some delay in that so that you delay each request to allow for the rate limiting or to avoid the rate limiting, let's say. If you have a list of login credentials that comes from a leaked database, for example, the RockU aggregation, where you know which password is connected to which email address, you can use the pitchfork attack in the intruder to perform a process called credential stuffing, where you use the application as an oracle to determine if a user has an account on the service. And then you can also verify if the same password has been used for the account. And you could deduce from that that specific user reuses that password over multiple services, and that opens up a much larger attack surface or the possibility for directed attacks to a certain user. In the Extender tab of B𝗏𝗏, you have an entire marketplace where you can find some custom packages that serve specific purposes that are not present out of the box in B𝗏𝗏. And that can range from extending existing tools, such as the intruder, to adding some scan types to the scanner itself. And then some extensions add an entirely new tab to the interface with some separate functionality. And a couple of examples of that. So in the first place, retire.js is a tool that can also be installed standalone that adds checks to the scanner for outdated and possibly vulnerable dependencies in the application. Especially nowadays, applications are heavily dependent on external frameworks and packages, and retire.js scans those to see if there are any known vulnerabilities in those. Then you have the turbo intruder, which extends the built-in intruder for brute force attacks, etc. And among others, you have the possibility in Turbo Intruder to write your own Python scripts to handle word lists, process requests, etc. So it's very extensive. And with Python, of course, you can program any type of logic you want to handle those requests that you're sending or the data that come from it. Then you have Param Miner, and as you can deduce from the name, it's an extension that gathers all sorts of useful parameters from a request that you can later use for exploitation. And then finally, JSON Web Tokens is one of the extensions that I like the most, and it highlights any request that has a JWT token or an authorization token in it in the proxy or in any other tool that that you have in B𝗏𝗏 that lists the requests. And finally, B𝗏𝗏 Professional also contains a tool called Collaborator. And that allows you to trigger out-of-band indirections to a dedicated server where you can consult the requests. And a notable example of this is when you succeed in performing a SQL injection attack, which I'll show later. But the application doesn't reflect the response of the query directly in the front end or in the payload that is returned. What you could then do is write a SQL query or send a request in SQL that triggers an interaction from the SQL server to the collaborator server, where you include a concatenated string of any query you execute as a subdomain, so that you see the data that are retrieved from the SQL query in the request that is sent to the collaborator server in B𝗏𝗏. So that's the theoretical presentation, let's say. And now it's time for a demonstration of some of these functions in b𝗏𝗏 that I mentioned. So I'll switch over to the b𝗏𝗏 tool. So as you can see here, first of all, I'll start an application that has some vulnerabilities built in, which has been developed by OWASP. It's one of their flagship projects, and it's called the Jew Shop. And it's a simulation of a web shop that has some vulnerabilities in there that you can test or that you can train on using b𝗏𝗏 or any other tool, of course. So I have the application running on port 3000 on my local host now. Of course, I'm not going to use an application that's hosted on the internet. It's always kind of dangerous to do that, of course, unless you have the permissions to do that. So as you can see here, you have all those tabs on the top. So I'll move over to the proxy tab, like I said, the most important one to start off with. Here you have the intercept button with which you can intercept requests directly, but I'm not going to do that here. I'm going to open the built-in browser in b𝗏𝗏. It's a Chrome browser that's built in. And so I'll navigate to the local hosts, to the Jew shop that's running there. And as you can see, it's a web shop where you can purchase juices or any juice paraphernalia. And so what I'll try first is I'll try to log in to an account, to any account. So I don't have an account registered on here. You could also register an account and see what you can do within the application. But what I'm going to do here is start from scratch, trying to breach the application in two different ways. So I'm going to try to breach the administrator account specifically in two different ways. So first of all, I'll try to log in with some random credentials that I know that are not correct. And as you could expect, we get the message invalid email or passwords. And in the meantime, in the background, b𝗏𝗏 gathered those requests in the HTTP history of the proxy. And there you can see all these requests that were executed, including fetching the resources and the JavaScript, etc., that runs. But the request I'm most interested in is this one right here, the post request, where I actually performed the login. And there you can immediately see that we have a payload here with email and passwords. And the first thing I'm going to try is to find a SQL injection vulnerability, which is where when you try to log in, the backend is most usually going to try to find the user account in the users table in the database using the values that you passed along in the payload. In this case, I'm going to use the repeater to perform those requests. So I can right-click the request here, and I can send it to the repeater, which is one of those tools at the top. You can see here that the intruder and the repeater have shortcuts, short keys assigned to them. That's because they're the most commonly used tools when you manually test a website or a web application for security. So I sent it to the repeater. You can see here that it highlights the repeater and it added the requests to the list of requests here. You could also draft your request manually as well. But in this case, I'll use the existing one, of course. And I'm going to try a very simple SQL injection where I'm going to try to close the query that it does in the users table in the database. And then I'm going to add an always true statement to the where clause and then comment out all the rest of the query. I'll show you the resulting query in a second. So the one I'm going to try is I'm going to insert in the email field instead of a regular username. I'm going to insert a single quote followed by or 1 equals 1, which is always true. And then I'm going to put 2 dashes here to comment out the rest of the query. The way you can execute those SQL injection or the way you can try those SQL injection exploits sometimes depends on the type of database as well, of course. So SQL Server, Oracle, etc. They have similar syntax, but the syntax might differ a little bit. So if you're trying to execute more advanced SQL injection attacks, you might have to adapt to the actual database accent or the database type that you're performing it on. There are ways also of determining that, but in this case, it's a very simple one that is most common to most SQL syntaxes. So close the quotes, always true, and then comment out the rest. And then I'll send the request. And then you can see that I immediately get an authentication token back, which I can then use in other requests, or I can just log in the front end of the application using this specific SQL injection. I'll show you the resulting query. So in the database, in the end, I can also show you that with a scan later on. The resulting query would be something like this. So we do a select from the users table, or the backend rather would do a select from the users table, where the username equals, and that's the value that you pass along in the username field. In this case, what I selected here is the value that I entered in the username field. And then it closes off with a single quote, and it also checks the password or the hashed password, etc. But this way you can actually just entirely bypass the password check by commenting out the end of the query. So if this query is executed, it's just going to fetch the first user or all users in the list, and it's going to take the first user in the list to log you in with. Because notice that I didn't actually enter a username, so the backend is incapable of knowing which user it has to log in. So usually it's going to take the first one on the list because there's a unique query that checks for username and passwords for the unique username. And I'll show that in the front end as well. So I'll actually try to log in with this query. And you can already see that the Jew shop, it also has a scoreboard built in, and it notifies you when you have solved a certain challenge that's present in the Jew shop. And in this case, log in with the administrator user's accounts. Later on, we'll see the second way of doing that. So in this case, I'm just going to add or e1 equals 1, comment it out, log in. And then you'll see that we're logged in with the administrator's accounts. There we go, with a nice hacker image right here. So now I'm going to log out of the application. It's a bit slow in loading, but that's because it's not running on my PC. So I'm logged out again. And the next thing I'm going to try is I'm going to try to show you. I'm going to show you an alternative way of trying to log in with the administrator's account. The first thing I'll do is I'll explore the website a little bit. So I'll gather some information, any information I can find on the website. And for example, of course, I already know this, but usually you would just click around in the website and check all pages or all pop-ups that you can see and all the information that you have there and investigate the requests that it does in the background. In this case, I opened up the details of this specific juice. In any case, so we have the reviews here, and you can see that the admin posted a review on this specific apple juice. That's already something that's kind of insecure, that the email address is shown here. That shouldn't be the case in an application, of course. It should be a custom username that you set in your user account, never your email address. It should not be revealed in reviews or anywhere else on a web application, of course. So I'm going to copy the email address. I'm going to go back to Burp Suite. And this time I'm not going to use the repeater, but I'm going to use the intruder. So I'm going to send the request to the intruder. There you can see it already detected some parameters that could be interesting to exploit. But in this case, I'm going to clear all those parameters. So we start from scratch. I'm going to replace the email address with the actual email address that I retrieved from the review in the front end. And then the password itself, because I don't know the password. If I would try this request, it would fail because I don't know the actual password of the admin account. So I'm going to set the password as a parameter. As you can see here, now it's highlighted as a parameter. And then I'm going to select the attack type. Usually, if you would use a combination of a password list with emails and passwords, you would use a cluster bomb, which would execute or try to perform requests on all the permutations of that list. So combining all email addresses with all passwords that are in the list. But in this case, since we only have one parameter, I'm going to take a sniper attack, which is just going to inject the payload in that one parameter that I have here, the passwords. Yeah, was already selected. It's the default one here. So now that I have determined or set the parameter, I can go to the payloads tab in the intruder. There is only one payload set because I only have one parameter. I can select the payload type. You have all sorts of possibilities in there. In this case, I'm going to use a simple list where you just paste a list of known passwords or most common passwords into it. and try to verify if the admin account uses one of those common passwords. But you also have a whole bunch of other possibilities in here. Some custom iterators, so you can also put dates in there. You can put numbers in there that you increment numbers in a certain field. You also have a username generator, or for example, if you do a targeted attack to a specific domain, you could take the top level domain, so the @bridest.be, for example, and then use the username generator to generate everything in front of the top level domain in the email address. But in this case, like I said, I'm going to take a simple list. For this demo, I downloaded a specific list of a top 100 of most common passwords used. So I'm going to use that one. I'm going to select the list. I'm going to paste it into the payload set in the intruder. And as you can see, it already calculates the payload count right here and the number of requests. So I have 100 passwords. So it's going to perform 100 requests. And it's going to try each of those passwords to match it with the email address in the username field. If you would have a cluster bomb attack with the permutations, the number of requests would be much higher, of course, since it would be multiply the number of the email addresses or the amount of email addresses with the amount of passwords. And then you also have some payload processing at the bottom here, as you can see, and you have the resource pool at the top here, where you can define some delays between the requests, etc. Because I'm running it on localhost right now, I'm not going to do that because I don't have any rate limiting setup here. So I'm just going to start the attack in the top right here. And as you can see, it performs all these requests. You see the response status, so 401 unauthorized for most of them. But if I order by status, you can see that there is one response that has a 200. And also it highlights that it contains a JWT token in the response in this case. That's the extension that I used for the JSON web tokens. So I'll show that in the extender right away. So when I click this one, you can see the actual request it performs, and you can also see which password from the payload that it used and that has had a successful response, which you can see here, the authentication token. All the other responses would be an unauthorized response. So that's for the intruder. I'll close this attack, and then I'll show you the extender, which is where you have the marketplace with also all types of extensions you can add to the tool. The ones that I have installed right now is Retire.js, JSON Web Token, Turbo Intruder, a deserialization scanner for Java specifically, and the param miner. I just recently reinstalled my computer in my Burp suite, so the list is kind of empty, but usually you would have like a large list of useful extensions in here to use for testing. And the final thing I'll show you is the scanner. So I'll go back to the login request, and I'll right-click it, and I'll do an active scan on it. And you can see that it highlights the dashboard here, and it starts an active scan on the endpoint. Usually you would do that for the entire application, of course. You would just simply scan an entire application or a scope that you determine for performing the scan on. First of all, it's going to do an audit. So it's going to try to determine all the paths that are present in the application. But because I selected a specific path here, there's only one. And then after that, it's going to do an actual scan for the issue activity. You see that it finished here. Yeah, sorry, I was wrong. It's not an audit on the items. It's first a determination of all the paths that are there, which is a crawl, and then it does the audits, which determines the issues or finds the issues. And you can see here that we have a SQL injection issue with the requests and the responses that it tried during the scan. And you can already see in the first request that it added this type of injection, so a username and then close the request with a quote. And in the response, we get an error because it actually has two quotes at the end of the where clause in the user field. And also, which is very insecure as well, is that it shows you the requests, the actual SQL query that it did in the background. So if you would try something like this in a request and you get this type of response, you can immediately see, okay, this is the actual database query. So then you can start working from there and start manipulating it. So let's see, and I think that's about it. So I'll go back to the presentation. That's the previous slide. So as a conclusion to the presentation, to conclude the brown bag, I listed some resources that are interesting to continue your journey into security testing if you would be interested in it. And a good starting point is the free web academy offered by b𝗿𝗟𝘄𝗏, the company behind Burp_Suite, where you have a whole bunch of topics you can train in specific lab environments using Burp_Suite. And usually the community edition is sufficient for most of those labs. For some of them, you would need the professional edition. Then you have Integrity, which is a bug bounty platform, which offers vulnerability testing programs from companies, which ranges from banks to corporations such as Intel, etc. Tomorrowland is in there, 𝘚𝘌𝘚𝘐𝘚, etc. And if you would like to get certified in security testing on a broader level, not only limited to web applications, two notable certifications are Certified Ethical Hacker, which is a mostly theoretical exam, and then you have Offensive Security Certified Professional, OSCP, which is from Offensive Security, who are also the makers of Kali Linux, another penetration or common penetration testing tool. And the OSCP certificate has a more hands-on approach, also with interactive labs. Just like the b𝗿𝗟𝘄𝗏, but more elaborate and also more on operating systems and networking, etc. So thank you for attending this brown bag, and I'll say that we move over to the Q&A. So if there are any questions, fire away.
Thank you, Bart, for a nice presentation. Just a quick question. You said, okay, for the automatic scan, that it's a good starting point, but from then on, you have to do some manual tests as well.
Yeah.
When you do your manual configuration, can you add it to the scan afterwards?
You mean if you have a specific scope or specific endpoints you want to test, or because in any case, when you set up the scanner, you can actually add a whole range of configurations to it. For example, you can determine a scope which you can limit to a certain part of the application. You can also include some processing or some pre-requests. For example, try to authenticate or try to register even on the website before you actually run the scan. But usually you would work the other way around. So you wouldn't start with a manual test. You would start with a scan of the application, and then investigate the result of that scan, see if there are any issues that were already found, and also use the scan as a starting point for the scope. So as a starting point for all the paths that have been discovered in the crawl. And then you can use that scope to start your manual testing. But the manual testing usually also involves trying to detect additional paths or trying to explore the application further than the scan has done. So actually, I would say it's more the other way around. Everything that the scan does, you can use afterwards in the manual testing. I hope that answers your question.
Yeah, thank you.
You're welcome.
Are there any other questions?
Maybe one more for Burp_Suite. How does it relate to OWASP? Are there real alternatives, or do they both have their specific strengths? Or
Yeah, well, initially OWASP was started as a proxy, as an attack proxy, simply to intercept requests. But gradually they also started adding additional features, such as the Selenium integration. But they both have their advantages and their disadvantages, of course. I think Burp_Suite is actually the more elaborate tool, especially thanks to the extender, the extensions that you can install, etc., and also the built-in tools. Whereas OWASP might be a little more limited in that sense, also because it's open source, of course. OWASP is entirely free to use, whereas Burp_Suite, the community edition, has most of the functionality, but the paid versions offer a whole lot more.
Yeah, I see. Okay, thank you.
Yep, you're welcome.
So, okay, thank you all for joining. Hope to see you next time, and voilà, have a nice working day. Bye-bye.
Bye, everyone, and thank
Bye.
you.
Thank you, Bart.
You're welcome. Bye-bye.